So beta, are we back?
Yes, sir.
Very good. So चलें बेटा शिप्स मैग्नेटिज्म पे चलें. Okay, let's go. Now let's move into the ship's magnetism. We have already discussed about the Earth's magnetism. Earth's magnetism is what affects our magnetic compass and provides the directive force to the compass. Now, ship's magnetism is another force which is very much present at the compass location and it affects our compass. So we are going to analyze what type of magnetism is present in the ship and how does that magnetism of the ship affects the compass in a positive way or in a negative way, and eventually in the end we are going to see how do we counteract or compensate the effects of the ship's magnetism on our magnetic compass. So let's go into these concepts one by one. Now, in the olden days, the ships were made of wood. Wood was a non-magnetic material and would not have any magnetism of its own. On such a ship, the only force which affects the magnetic compass is the Earth's magnetism, and the compass would point in the direction of the magnetic poles. Once we identify the magnetic poles, if we apply the variation, we can easily find out the direction of the geographic poles also. So things were pretty straight and simple. But nowadays, ships are being built of steel, which is a ferromagnetic material. Steel or mild steel or iron is a ferromagnetic material and it has the capability to acquire magnetism. We have seen in the previous slides that two types of magnetism can be generated in ferromagnetic substances. One is permanent magnetism, which was generated by bringing it in contact with a permanent magnet in a specific way. And the second was induced magnetism, which is generated when any ferromagnetic material comes under the effect of a magnetic field. So this mild steel, being a ferromagnetic material, can acquire magnetism of its own. And as we have already discussed, the acquired magnetism by the ship, by the steel of which the ship is made, could be either induced magnetism or it could be permanent magnetism. So these are the two types of magnetism which could be present in the ship structure. Any doubts up to here, beta? Very good, beta. Moving ahead. Now, based on what type of magnetism is acquired by a particular structure or part of the ship, it is divided into two types. All the structures are divided into two categories. The first category is known as soft iron structures, and the second category is known as hard iron structures. Let us see them one by one. Induced magnetism of the ship is acquired by those parts of the ship or steel structures which instantly and easily get magnetized when placed in a magnetic field. Also, they immediately lose their magnetism as soon as the magnetic field is removed. These type of materials or structures are termed as soft iron structures. Any doubts up to here, beta? Okay, let's move ahead. Now moving on to the hard iron structures. Permanent magnetism of the ship is acquired by those parts of the ship or steel structures which offer substantial resistance to magnetic changes. These materials do not get magnetized easily, but once magnetized, they retain their magnetism permanently. Now, these kind of structures or these type of materials are termed as hard iron structures. So basically the ship is divided into these two kinds of structure, the soft iron and hard iron structures. Soft iron structures gain or acquire magnetism very easily, and that acquired magnetism is induced magnetism. It is temporary in nature. As soon as the inducing field or the magnetic field which was responsible for the magnetism is removed, the structures lose their magnetism instantly. Whereas on the other hand, the hard iron structures, they do not acquire magnetism easily. Just the presence of magnetic field is not sufficient to acquire magnetism in those structures. But if they get magnetized, then the magnetism remains there permanently. They do not lose their magnetism easily. Now, one more thing to understand before we proceed ahead. It should be very much clear in your mind that these hard and soft words which we have used in the definitions, hard iron structures and soft iron structures, they are basically denoting the two different types of structures or material having different magnetic properties. They relate to their magnetic properties or magnetic behavior. And these materials are not literally hard or soft to touch. Both of them are made up of steel, iron, so they are equally hard or soft to touch. It is not that a soft iron structure is very soft to touch. No, it is not that way. Do not take the meaning of the words literally. They are just denoting their magnetic properties or magnetic behavior. Any doubts up to here, beta? Okay, great. Let's move ahead. So going a little more further into the hard iron and soft iron, although no structure on the ship can be categorized as entirely or 100% a hard iron structure or a soft iron structures, because any structure on board a ship will possess both the properties in varying degrees. Some part of it will acquire magnetism very easily and lose it equally easily, and some part of the structure will acquire magnetism very slowly, and once acquired it will not leave. So if every structure has both these properties in it, how do we classify them as hard iron and soft iron? Now these are generally classified on the basis of which out of the two magnetic behavior is predominant in that structure. Let us say we have a particular structure. Let us say we have a mast. Now in that mast we analyze and find out that 70% of it has soft iron magnetic properties and 30% acquires or has the hard iron magnetic properties. So since predominantly most part of it is a soft iron magnetic behavior part, we will term the mast as a soft iron structure. The ship structures which are generally prefabricated, means they are made in the factory or made in the yard and fitted on board in situation. Uh, structures could be the transverse beams, the fore and aft longitudinals, the vertical stiffeners, the mast, the funnel. All these kind of structures, if you see a ship being built in the yard, you will see that all these structures, the beams, the longitudinal, vertical stiffener, mast and funnels, they are basically prefabricated in the yard. They are picked up by a crane, brought to the place where the ship is being constructed, and they are held in place and they are welded there. So these kind of material which are prefabricated predominantly exhibit soft iron magnetic behavior. On the other hand, the ship structures which are extensively worked upon. By worked upon, we mean when the ship is being built, there's a lot of welding or heating or hammering, bending, grinding, cutting. These kind of processes are being made or carried out on those structures. These structures could be the ship's hull, they could be the bulkheads, they could be the decks. Now these kind of structures predominantly exhibit hard iron magnetic behavior. Any doubts coming up to here, beta? Very good, beta. Excellent. Let's move ahead. Now we are going further into the soft iron and hard iron structures. Any doubt is there, beta?
Yes, sir. Sir, these soft iron, do they have any kind of age limit or time limit? Like after
No,
2 years or 3 years, they will lose their
no,
magnetism?
no. If a structure is a soft iron structures, for the entire life of ship, it remains soft. If it is a hard iron, for entire life of the ship, it remains hard.
Okay.
Okay. Okay. Let's go ahead now. Because this is a very important concept to understand the working as well as the correction of the magnetic compass. The soft iron structures which are present on board, they can be classified into two different categories. These are the vertical soft iron, which has a vertical orientation. It could be the vertical stiffeners. The vertical stiffeners are welded onto the bulkheads, so they have a vertical orientation. Or you could have the masts, forward mast, any cranes, the crane houses, the aft mast, and you have the funnel. All these structures have a vertical orientation on board. The second type of soft iron structures could be horizontal soft iron structures. Now, horizontal soft iron structures could be the fore and aft longitudinals. It could be the athwartship beams. Both the longitudinals as well as the beams are welded on top of the decks or top of the keel plate or at the bottom of the, you can say the top deck of the tanks. So they have a horizontal orientation. So these are the two different categories into which the soft iron is divided. In short, the vertical soft iron is also known as VSI, and the horizontal soft iron is known as HSI. Any doubts up to here, beta?
Sir, the slider is paused or you are still showing any other slide, because ship magnetism slide is showing in my mobile.
Beta, what slide are you seeing on your screen? Is it soft iron types?
No, sir, ship magnetism.
Okay, so that means your connection is little bit dicey. You may log out and log in again. What about others, beta? Are you able to see soft iron types?
Yes, sir, soft iron types.
That's right. ओके बेटा ओके अगर आपकी स्क्रीन फ्रीज हो रही है बेटा तो इसका मतलब है कि बैंडविड्थ में नेट में कहीं पे कोई इशू आ रहा है So if you wait, it may sometimes start to move. If it is not moving at all, you can log out and log in again.
Okay, sir. Okay, sir.
Okay. Okay. Now, if you consider a horizontal soft iron, as I told you, a horizontal soft iron could be a fore and aft longitudinal or a athwart ship beam. The horizontal soft iron structures on board are magnetized by the horizontal component of the Earth's magnetic field known as H or HF. Now, when we discussed the magnetic field of the Earth, in that we discussed that at any particular place on the Earth's surface, the total magnetic field intensity represented by this slanting vector can be divided into two components. The horizontal component known as H or HF and the vertical component known as Z. Now, why have we divided them into components? So that we can understand the effect of Earth's magnetism easily onto the ship structure and onto the compass. Now, obviously, if you have a horizontal soft iron structure on board, it will be magnetized by the horizontal component of the Earth's magnetic field, that is H or HF. Now, how is it affected? Now, a blue pole is acquired where the lines of force enter the material, and the red pole is acquired where they leave the material. Now we have seen this that every magnet has its two poles, the blue and the red pole, and we have seen red pole is the one from where the lines of force come out, and blue pole is the one where the lines of force enter into the magnet. So same thing applies here. Let's assume we have a ship which is on a northerly course, 000 course. The ship is at the equator. Now, if you visualize a ship on equator on a heading of 000, you will see that the magnetic lines of force at the equator, they are also parallel to the Earth's surface. They are also horizontal, and they will be entering from the stern of the ship, and they will be leaving from the bow of the ship. Now, if we have a fore and aft longitudinal, the magnetic lines of force will be entering into that end of longitudinal which is toward the stern. And since the lines are entering there, it will have a blue pole at that particular location. Going to the forward end of the fore and aft longitudinal, the lines of force will be coming out from the forward end. So the forward end of the longitudinal will acquire a red polarity. So this is the meaning of the second sentence. A blue pole is acquired where the lines of force enter the material, and a red pole is acquired where they leave the material. Now the strength of induced magnetism generated in a longitudinal is a horizontal soft iron structure. So when it is exposed to the magnetic field of the Earth, it acquires magnetism. But the strength of the induced magnetism depends on the heading of the ship. Let's understand this by taking this example. Now we know that the H component, the horizontal component of the Earth's magnetic field, always acts northwards. So therefore, the horizontal soft iron structures will receive maximum induction if they lie in the north-south direction. And they will receive zero induction if they lie in the east-west direction. You remember when we discussed about the induced magnetism, I told you that the strength of the induced magnetism depends upon the orientation of the soft iron. If the soft iron structure is oriented or aligned in the direction of the magnetic field, maximum induction would occur. And if it is misaligned, that means it has a orientation perpendicular to the direction in which the field lines are going. It will have minimum or negligible induction. So taking this example, we had a vessel heading in the northerly direction. So a vessel which is heading north, the fore and aft longitudinals, which will also be heading in the lying in the north-south direction, will receive maximum induction from the magnetic field of the Earth. The Earth's magnetic field also is in the north-south orientation. So they are perfectly aligned with the magnetic field of the Earth, generating maximum induction. So with maximum induction, it will have strong magnetism acquired. And if you now concentrate on the outward ship beams, our vessel is heading in a northerly direction. So the fore and aft longitudinals were perfectly aligned with the magnetic field, but the outward ship beams on that ship will be oriented in a east-west orientation. Now the magnetic field of the Earth is going in a north-south direction. The outward ship beam oriented in a east-west direction. So they are at right angles to each other. So totally misaligned with the magnetic field of the Earth. So this tells us that there will be zero or negligible induction on the outward ship beams with the ship lying in the northerly heading. So a ship is on the northerly heading. The fore and aft longitudinals will have maximum induction and the outward ship beams will have negligible or zero induction. So your doubts now beta up to here?
Sir, induction means that the magnetism is going from the stern to the forward part, right?
That's right, beta. The lines are entering from the stern and leaving out from the bow.
Okay, sir.
So this is in case where the north.
This is in case the heading is not northerly direction, sir.
Right, beta. That's right.
Okay, sir.
So we are heading towards the north, and we are like parallel to the magnetic field. Okay, and the magnetic field is entering from stern and going out from your head. How does that make the vessel a horizontal soft iron? Because it seems we are parallel to the magnetic field, correct? It makes it a vertical soft iron, correct?
Beta, the ship's fore and aft longitudinal, concentrate, visualize in your mind, आपका ship है, उसमें एक fore and aft longitudinal है, उसकी जो orientation है वो horizontal है ना बेटा? It is parallel to the earth surface.
Yes.
And the earth's magnetic field is also horizontal. So ये जो फोटो आप देख रहे हो, this is basically a top view of the ship. जैसे आपने एक ड्रोन से ऊपर जाके फोटो खींची है. That's how this photo is.
So basically, irrespective of the heading, our fore and aft longitudinal will always remain a horizontal soft iron.
It will, the fore and aft longitudinal as well as the outward ship beam will always remain a horizontal soft iron. The funnel, the mast, the cranes, it will always remain a vertical soft iron irrespective of the ship's position or any heading, anything.
Okay. And this red point and blue point on the vessel, it will change depending on which heading we are.
Certainly, beta. If you move on a easterly heading, the fore and aft longitudinal is going to lose everything and the outward ship beam is going to acquire maximum.
Okay, thank you. Thank you.
Sir, I am not able to visualize this H component in north, acting north.
ओके बेटा, ओके बेटा, आप बस इतना याद रखो कि अर्थ का जो साउथ पोल है वो रेड पोलैरिटी का है.
यस सर.
और जो मैग्नेटिक नॉर्थ पोल है वो ब्लू पोलैरिटी का है.
यस सर.
So the lines will always be going from red to blue. Red से बाहर निकलेंगी और blue में enter करेंगी. So the lines will always be going towards the north magnetic pole, right?
Right, sir.
Just remember that much. It will take care.
So then, this one that it like north and south heading.
बेटा आपकी आवाज़ बड़ी बीच में ब्रेक हो रही है. Speak little slowly, closer to the mic.
Sir, I am saying that this thing is okay, sir. But how I will came to know that it is maximum at north and south heading by understanding.
ओके मैक्सिमम बेटा हमें इसलिए पता चला क्योंकि हमारा जो 4.5 लॉन्जिट्यूडनल है इट इज़ इन द सेम डायरेक्शन एज द अर्थ्स मैग्नेटिक फील्ड लाइन. हमारा जो 4.5 हॉरिजॉन्टल सॉफ्ट आयरन है वो भी साउथ टू नॉर्थ की डायरेक्शन में है. सो व्हेन इट इज़ अलाइंड इट विल हैव मैक्सिमम इंडक्शन.
Okay, Professor. Whenever any ship is aligned, any soft horizontal soft iron is aligned in 4.5 direction, like long 4.5 long, they will be having maximum maximum value, sir. North south heading.
दैट्स राइट बेटा, दैट्स राइट.
सर सर शिप के जो पॉइंट है रेड एंड ब्लू ये ऑलवेज अपोजिट रहेंगे अर्थ पोल के.
बेटा इट ऑल डिपेंड्स अपॉन कि लाइंस कहाँ एंटर कर रही हैं और कहाँ से एग्जिट कर रही हैं. जहाँ भी लाइन एंटर करेगी वो ब्लू पोलैरिटी लेगा, जहाँ से भी लाइन बाहर निकलेगी वो रेड पोलैरिटी लेगा.
ओके ओके अंडरस्टूड.
ओके
ओके
सर सर पर नॉर्मल केसेस में जैसे अभी अपन ने व्हेन शिप इज हेडिंग टुवर्ड्स द नॉर्थ और पैरेलल में है तो ब्लू से ईस्टर्न से एंटर कर रहा है और बाव से वो कर रहा है, निकल रहा है. पर इसको अगर अपन 180 पे रख लेते तो इसका अपोजिट हो जाता. दैट्स करेक्ट सर.
naturally beta the bow will have a blue polarity then and the stern will have a red polarity.
मतलब बेसिकली अर्थ मैग्नेटिज्म के बेसिस पे ही शिप की वो आ रही है पोलैरिटी. मतलब नीचे ब्लू था, साउथ पोल पे ब्लू था, इसलिए वो ईस्टर्न अभी ब्लू पे है और नॉर्थ अभी रेड पे है, ऐसा.
That's right बेटा, horizontal soft iron है वो तो अर्थ के मैग्नेटिज्म के बेसिस पे ही अक्वायर करेगा.
ठीक है सर. और सर ये अगर जैसे इक्वेटर के पैरेलल होता तो फिर इसमें पोल क्या डिवाइड होते?
इक्वेटर के पैरेलल यू मीन वेसल इज हेडिंग 090?
हाँ 090 या 000.
शिवांग बेटा तुम्हारा क्वेश्चन समझने के लिए मेरा पूरा दिमाग लग जाता है. Instead of saying parallel to the equator, just say if the ship is on a 090 heading.
हाँ 090 या 270 पे इन दोनों में से किसी पे हो तो पोल क्या होगा?
तो बेटा पोल जो बनेंगे वो आपके ऑर्थवर्ड शिप बीम पे बनेंगे, लॉन्जिट्यूडनल पे नहीं बनेंगे. एंड ऑर्थवर्ड शिप बीम का जो स्टारबोर्ड एंड है उस पे ब्लू पोल बनेगा
वो
और
आपका
जो
ब्लू पोल हो जाएगा.
यस.
अच्छा ठीक है सर, ठीक है.
ओके लेट्स गो. Now from this we are able to understand that the magnetism generated in the horizontal soft iron depends on the heading of the ship. We have seen this ship heading in the northerly direction. There was maximum induction in the 4.5 longitudinal and there was zero induction in the northward ship beams. You can imagine it in this way now. Let us assume that this particular ship which was heading in a northerly direction now changes its heading and alters its course, and now it is heading in the east-west direction. If the ship is heading in the east-west direction, you can now see that the 4.5 longitudinal is also lying in the east-west orientation and it has become perpendicular to the magnetic field of the earth, which is lying or running in the north-south direction. So when the ship alters course to 090 and is moving on a easterly track, the 4.5 longitudinal are going to lose their induction. There will be no magnetism or negligible magnetic field acquired or generated or induced magnetism generated on the fore and aft longitudinal. Now, on the other hand, the outward ship beam in this condition, with the ship heading east, the outward ship beam are now lying in the north-south orientation. The Earth's magnetic field is also in the north-south orientation, so they are perfectly aligned with each other, generating maximum possible induction on the outward ship beams. Thus, the magnetism generated in HSI depends on the heading of the ship. Because as the heading of the ship changes, the orientation of the HSI with respect to the magnetic field of the Earth also keeps on changing. The induced magnetism generated in a vertical soft iron or a horizontal soft iron will also change with the position of the ship. Now you see the basic cause of this magnetism, the induced magnetism in soft iron structure, is the magnetic field of the Earth. Now if the ship changes its location, let's assume that the vessel was on the equator and now it has moved towards the pole. Now as soon as the vessel changes its location, the Earth's magnetic field, which is the generating force for inducing the magnetism, also changes. So as the vessel changes its position, the magnetic field which is affecting the vessel also changes. The magnetic field at the equator is in a different orientation. Field lines are horizontal. Horizontal component is the strongest. The zero component, the vertical component is the zero component. Now as you move towards the pole, horizontal component keeps on becoming lesser and lesser and vertical component keeps on becoming stronger. If you go at the pole, you have zero horizontal component and maximum vertical component. So with the magnetism of the Earth changing with position, as the ship goes from position A to position B, the induced magnetism in the ship's soft iron structure is also going to change. Now the induced magnetism in the ship's structure will also change continuously when the vessel is rolling or pitching. Now when the vessel is rolling or pitching, the fore and aft longitudinal or the outward ship beam or the vertical structures, they are also changing their orientation time and again. With every roll and with every pitch of the ship, the HSI and the VSI are going to change their orientation. And as their orientation changes, the induced magnetism in those structures also changes. So your doubts now, beta?
Sir, I just want to ask कि अभी जैसे हम इक्वेटर के पास है तो हमारा मैग्नेटिज्म जो है हॉरिजॉन्टल पैरेलली जो है पैरेलल टू फ्रॉम साउथ टू नॉर्थ जा रहा है, करेक्ट, विद द अर्थ सरफेस,
राइट।
एंड जब हम नॉर्थ की तरफ जाते हैं तो हमारा वो एंगल बन के हॉरिजॉन्टल की जगह वर्टिकल हो जाता है एंड
राइट
मैक्सिमम डिग्री एट पोल्स,
राइट।
तो दैट केस सर हमारे जो बीम है लॉन्गिट्यूडनल बीम है, उस लॉन्गिट्यूडनल बीम्स में जो सॉफ्ट आयरन पे जो मैग्नेटिक फील्ड जो पास कर रहे थे साउथ टू नॉर्थ, पीछे आफ्ट टू फॉरवर्ड, वो और नहीं हो रहा है, अब ऊपर से हो रहा है। दैट मींस कि हमारा मैग्नेटिक का जो इफेक्ट है मैग्नेटिज्म में वो कम हो जाएगा। ये सही है सर?
हाँ बेटा, इसमें मैं एक चीज और ऐड कर दूंगा। जैसे जैसे आप पोल की तरफ जाओगे HSI में इफेक्ट कम होगा, VSI में इफेक्ट बढ़ना शुरू हो जाएगा।
तो सर VSI में HSI में तो समझ में आ गया सर कि सॉफ्ट आयरन में, लेकिन VSI वर्टिकल सॉफ्ट आयरन जैसे मास्ट वगैरह इन सब में इफेक्ट बढ़ जाएगा।
दैट इज राइट बेटा, अगर आप पोल पे जाओगे तो वर्टिकल स्ट्रक्चर में मैक्सिमम इंडक्शन होगा।
ओके, बट इन एनी केस दोनों केस में सर हमारे मैग्नेटिक जो कंपास है वो इफेक्ट करेगा ही करेगा।
वो हम बाद में देखते हैं बेटा, पहले हम इसको समझ लें, फिर हम बाद में देखेंगे कि ये हमारी कंपास को कैसे अफेक्ट कर रहा है।
ओके सर, कॉपी।
सर जैसे अभी इन्होंने बोला, तो वर्टिकल जो मास्ट है, मतलब जहाज अगर इक्वेटर पे 090 चल रहा है तो वर्टिकल मास्ट में बिल्कुल भी इफेक्ट नहीं होगा, ऐसा? मतलब जीरो हो जाएगा इफेक्ट।
दैट इज राइट बेटा। आप अगर इक्वेटर पे हो, शिप को किसी भी हेडिंग पे ले जाओ फ्रॉम 000 टू 360, आपके वर्टिकल स्ट्रक्चर में कोई भी इंडक्शन नहीं होगा, क्योंकि वो वर्टिकल है और अर्थ का फील्ड हॉरिजॉन्टल है।
नहीं सर, अगर कोर्स ही चेंज हो गया, मतलब 0 0 0 0 हो गया, तो वो तो वर्टिकल पे इफेक्ट करेगा ना तब तो, या तब भी नहीं
नहीं बेटा,
करेगा?
अगर कोर्स 0 0 0 है वर्टिकल स्ट्रक्चर, तो फिर भी वर्टिकल है, और अर्थ का फील्ड तो हॉरिजॉन्टल है, वो तो अफेक्ट ही नहीं करेगा।
ठीक है सर, ठीक है।
राइट?
हाँ ठीक है सर, समझ में आ गया।
ओके
So
बेटा।
this is only in the
सर ये
case. This is
डिवाइड
only in the
करने का
case if
मतलब ही क्या हुआ सर? ये
so,
वर्टिकल सॉफ्ट आयरन एंड हॉरिजॉन्टल सॉफ्ट आयरन को तो दो पार्ट में, सॉफ्ट आयरन को बेसिकली वेसल पे डिवाइड करने का मतलब ही क्या हुआ अगर वर्टिकल सॉफ्ट आयरन डजंट कॉज एनी इफेक्ट?
इट विल कॉज बेटा, इट विल कॉज, एज आई टोल्ड यू, इसका इफेक्ट हम देखेंगे बेटा अभी आगे जा चल के।
ओके।
sir, so
बोलो बेटा बोलो।
if the vessel is rolling or pitching when we are at the equator.
राइट बेटा,
Okay, sir.
क्लियर है बेटा,
Sir, but in
चलें आगे।
magnetism for the short time.
मनदीप बेटा, तुम्हारी आवाज नहीं आई।
Sir, I am saying that in case of the rolling and pitching, the magnetism which is generated, the change of magnetism which is generated, that will be for a particular short time.
दैट्स राइट बेटा, दैट्स राइट, वेरी शॉर्ट टाइम। ओके ग्रेट, लेट्स मूव अहेड। Now we are aware that the horizontal component of the Earth's magnetic field, which is H or HF, this component is the maximum or the strongest at the equator, because 100% of the field, magnetic field of the Earth is lying in the horizontal orientation, making the H or HF very, very strong. And this horizontal component of the Earth's magnetic field is nil or zero at the poles, because at the poles the Earth's magnetic field becomes vertical and it has a zero horizontal component. So this actually gives us an insight into the induction in the horizontal soft iron structures also. The horizontal soft iron structures will therefore receive maximum induction at the equator and zero induction at the poles. So if we have a ship at the equator, it will have maximum induction generated in the horizontal structures. If the same ship goes to the poles, those horizontal structures will lose their entire magnetism, because the H or HF component of the Earth's magnetic field has vanished at the pole. Let's now move into the vertical soft iron on the ship, the VSI. Just as the HSI, horizontal soft iron on board, was induced by the H or HF component of the Earth's magnetic field, exactly in the same way, the vertical soft iron or VSI on board is magnetized by the vertical component of the Earth's magnetic field. The vertical component is represented by Z. Wherever the magnetic lines of force enter into the structure, it will acquire a blue pole, and wherever the lines of force leave a structure, it will acquire a red pole at that particular location. To give you an example, let's assume we have our ship now at the North Pole. If the ship is at the North Pole, the Earth's vertical component, Z component, is the strongest there. The magnetic field lines at the North Pole are going vertically downwards. So if a ship is standing on the North Pole, you will see that the magnetic lines of force will be going vertically downwards into the Earth's surface. बेटा किसी का माइक ओपन तो नहीं है? जस्ट चेक योर माइक्स. Thank you, beta. It is closed now. Thanks. Let's assume or visualize the mast on that particular ship. Let's assume the forward mast. Now with the vertical lines, the lines of force going vertically downwards, they will be entering from the top of the mast. Now this point where the lines of force enter, that is at the top of the mast, it acquires a blue polarity. Wherever the field lines enter into a structure or a magnet, a blue pole is acquired, and these vertical lines of force going downwards will be coming out from the base of the mast. So the bottommost part of the mast or the base of the mast from where the magnetic lines of force are leaving or going out gets red polarity. It acquires red polarity because wherever the lines of force leave or come out from a structure or a magnet, it acquires a red polarity at that location. Now let's assume that this same ship starts moving now. At the North Pole, the top of the mast was blue and the bottom of the mast was red. This ship has started traveling now, and this ship now has crossed the equator and gone into southern hemisphere, and it has reached the South Pole. Now the same ship is at the South Pole. We are aware that at the South Pole, the magnetic lines of force, they come out from the Earth's surface. Now when they come out of the Earth's surface, they will be entering the mast from the bottom, thus giving it a blue polarity. The bottom of the mast now acquires a blue polarity, and these lines of force will be leaving from top of the mast, giving it a red polarity. So you see, as we changed the hemisphere, with the change in hemisphere, the direction of the magnetic lines of force of the Earth also changes. In the southern hemisphere, they come out of the Earth's surface, and in the northern hemisphere, they go down into the Earth's surface. And with this change, the poles acquired by the vertical soft iron also change. The poles get reversed when the ship changes from one hemisphere to another. Your doubts, beta, now?
तो मेरे तो कुछ नहीं समझ में आया इस वाले केस में, क्योंकि जब अपन हॉरिजॉन्टल वाले में थे, जब हॉरिजॉन्टल सॉफ्ट आयरन कर रहे थे, तो उस समय जो अर्थ मैग्नेटिज्म था वो पैरेलल चल रहा था अर्थ के।
बेटा एक बात सुनो, हॉरिजॉन्टल वाले को भूल जाओ, फॉरगेट अबाउट हॉरिजॉन्टल। तो मुझे ये बताओ कि यहाँ पे क्या समझ में नहीं आया बेटा, ट्राई टू पिन पॉइंट, पिक अप ए लाइन एंड से मुझे ये समझ में नहीं आया।
सर इसमें जैसे अर्थ, जैसे शिप की जो पोजीशन है एट नॉर्थ पोल एंड साउथ पोल दोनों पे, तो मैग्नेटिज्म ऊपर से ज्योग्राफिकल नॉर्थ से ऊपर से एंटर कर रहा है, दैट इज अ ब्लू पोल, एंड साउथ पोल से एग्जिट कर रहा है।
बिल्कुल
तो
सही
इसने
बेटा,
दोनों एक्वायर कर लिए दैट। सर मैं जो पूछना चाह रहा हूँ, अर्थ का मैग्नेटिज्म की जो लाइंस है वो तो एक ही रहेंगी, या तो मतलब ज्योग्राफिकल नॉर्थ से एंटर करके, या मैग्नेटिक साउथ से एंटर करके इधर से नीचे से निकल जाएगा। पर
नहीं बेटा,
हॉरिजॉन्टल वाले में
नहीं,
अपन
एक चीज तुमने बोला अर्थ की मैग्नेटिक फील्ड लाइन सेम ही रहेंगी, सेम नहीं रहेंगी बेटा, उनकी ओरिएंटेशन चेंज होगी। साउथ पोल से वो बाहर आएंगी, नॉर्थ पोल में वो अंदर जाएंगी, ओरिएंटेशन विल चेंज।
हाँ हाँ, ये सर साउथ पोल से बाहर आएगी, नॉर्थ पोल में एंटर होगी। ये वर्टिकल वाले में समझ में आ गया कि ये पैरेलल हो जाता है, तो ऊपर वाला ब्लू पोल हो जाता है और नीचे वाला रेड हो जाता है, वर्टिकल मास या किसी भी वर्टिकल कंपोनेंट के लिए।
राइट।
पर इस केस पर जैसे ही आप हॉरिजॉन्टल का केस ले रहे थे अपन सर, जब हॉरिजॉन्टल कंपोनेंट ले रहे थे, तो उसमें भी तो ये सेम ही चीज जा रही थी, जब उसमें अपन ने उसे पैरेलल क्यों लिया था इक्वेटर के?
हाँ बेटा, उसमें भी सेम चीज हो रही थी, दैट्स फाइन। उसमें अर्थ का हॉरिजॉन्टल फील्ड हॉरिजॉन्टल सॉफ्ट आयरन को इफेक्ट कर रहा था, इसमें अर्थ का वर्टिकल फील्ड वर्टिकल सॉफ्ट आयरन को इफेक्ट कर रहा है। इट इज वेरी सिमिलर।
सर इसमें फिर ये जो डिप होगा ये 90 डिग्री होगा क्या?
Yeah, that's right, beta. At the pole, dip will be 90 degrees.
ओके एंड ये जो वर्टिकल सॉफ्ट आयरन है अगर इक्वेटर पे जाएगा तो इट विल हैव अ नेग्लिजेंट इफेक्ट राइट
That's right, beta. You understood it perfect. Equator पे VSI will lose its entire magnetism, induced magnetism.
नोटेड थैंक यू
हाँ ठीक है सर, समझ में आ गया। मतलब पर्टिकुलर इंटेंसिटी के दो कंपोनेंट हैं, उसके हिसाब से डिवाइड करते हैं। ठीक है सर,
Excellent, beta. Great.
मतलब
great.
इसमें वर्टिकल कर रहे हैं और उसमें अपन हॉरिजॉन्टल कर रहे थे और
Exactly.
दोनों का
That's
रिजल्ट
right.
ठीक है।
That's right, beta.
ठीक है,
That's
ठीक है।
right. Okay. So it is mentioned in this last point here, positioning of the poles. That means whether the blue pole will be on top of a vertical structure or the red pole will be on top of a vertical structure will depend upon the hemisphere the vessel is in presently. The same thing which we just now mentioned, since the Z component acts downwards in the northern hemisphere and it acts upwards in the southern hemisphere, the magnetic poles generated on these vertical structures, the VSI, will reverse their polarity when the vessel changes its hemisphere. The heading of the vessel does not play any role or does not affect the induction in vertical soft iron structures in any way. Now, you could be heading in any particular direction in the northern hemisphere, but the lines of force will always be going downwards, making the top end a blue pole and the bottom end a red pole. So the heading of the vessel does not play any part in the induction or the polarity of vertical soft iron structures. The heading was important in case of HSI because when the heading changes, the orientation of the HSI with respect to the Earth's field also changes. But the heading has got no role to play in the induction of VSI, irrespective of which heading are you in. The polarity or the induction in VSI remains the same. Now we are aware that this vertical component is the strongest or maximum at the poles and it is nil at the equator. Therefore, the vertical soft iron structures will receive maximum induction at the poles and zero induction at the equator. Now moving further to ship's permanent magnetism. Till now we have gone in detail and understood the induced magnetism of the ship, which is acquired by the soft iron structures. We have seen their relationship with the heading of the ship, with the position of the ship, whether the ship is on the equator or at the pole, southern hemisphere, north hemisphere, horizontal soft iron and vertical soft iron in detail. Now we move on to the ship's permanent